This video goes along with the notes of 6.5 for my PreAP classes only. The notes for regular classes are different. So first of all, I would like you to pause the video and write down your own definition of roots of a function. Okay, what do you remember about those? What are they? Other words for the roots of a function are the zeros or the x-intercepts of a graph. Alright, so this is where the graph crosses the x-axis, or when y equals 0, it's whatever x equals. Alright, roots of a function are extremely important. You will use it over and over and over again, especially in pre-cal and calculus. So it's really good if you can remember this stuff and become really familiar with it. So the goal of section 6.5 is to find all the roots of a polynomial without a calculator. We're going to do this by first using the rational root rule to find all possible rational roots. When we say rational, we mean integers, and for a less official math word, and pretty fractions. Alright, that's what we mean by rational. Now, after that, we're going to use synthetic division, which you have used before, and we like that to find the true rational roots. Okay, so first we're going to find all the possibilities. We're going to narrow it down a little bit, and then out of those, we're going to find the ones that are really true. Once we get a rational root, we are going to use whatever methods we can left to find all the other roots. Okay, that could be factoring, quadratic formula, and the rule of conjugates, which we'll talk about in a little bit. Now, the rational root rule, that's what we're starting with, saying you have some polynomial, and the leading coefficient is q, and the constant at the end is p. Alright, so that's just a normal standard form polynomial. So it has to be in standard form, and it has to have integer coefficients. We don't want to do this with any fractions or decimals. So from that, we're going to take the factors of p and put them on top of the factors of q, and all of those are the possible rational roots. Okay, it doesn't mean they're for sure, they just have a greater chance than all the other numbers. So, whoops. Let's see how this works. It says find the rational roots of x cubed plus x squared minus 3x minus 3. First of all, is that in standard form? Yes. Alright, so with that, we're going to first find what p is. P needs to be our constant, which is -3. What are the factors of -3? We get 1 and -3, or -1 and 3. Alright, now we need q. This is our what we call leading coefficient. It's the coefficient of our highest degree term. Spelled that wrong. There we go. For us, this equals 1 factors of 1 are 1 and -1. Make sure you always include the negatives. So we need to put the factors of p over q. So our first one that we're going to use is 1 over 1. Well, 1 over 1 makes 1. Now we need 1 over negative 1. That makes negative 1. Negative 3 over 1. That makes negative 3. Negative 3 over negative 1. That makes positive 3. Negative 1 over 1. That makes negative 1. Wrote that down. Negative 1 over negative 1. That makes 1. We wrote that down. 3 over 1, that makes 3, got that. 3 over negative 1 makes negative 3, we got that. So we have 4 possible factors. We just went from having an infinite number of numbers that could be factors or roots down to just 4 of them. So that we seem like we're on a good track. We've narrowed things down. So now we're going to test them, see if they are true. If they are true, when we use them in synthetic division and there's no remainder, that means that it's a root. Okay, so if we have no remainder, it's a root, just like the rule we used the other day with factors. All right, so if we use 1, our coefficients are going to be 1, 1, negative 3, and negative 3. So we bring the 1 down, multiply, add it, multiply, add it, multiply, add it. Does that equal 0? No, so that is not a root. All right, let's try the next one, negative 1. So we get 1, 1, negative 3, negative 3. 1, multiply, add, multiply, add, multiply. Hey, yes, this one works. All right, so x equals negative 1 is a root. As we keep going, instead of using the original coefficients again, we're going to use these. All right, so now we're going to keep testing. So we've got negative 3. We're going to use 1, 0, and 3. Shorter problem here. Let's see what it does for us. Bring it down, multiply, add, multiply. No, that one doesn't work. Okay, so we're going to use those same coefficients again to test 3. 1, 0, 3. Bring it down, multiply, add, multiply. Oop, no, didn't work again. Okay, so our only rational root is x minus 1. For this next example, we're going to use the same process, but we'll just keep going with it and end up with all of our roots. Okay, so we're going to start with finding the possible rational roots. Okay, so possible rational roots. So we need p. P for us this time, it's your constant, so that's negative 1. Factors of negative 1 are 1 and negative 1. Q this time, leading coefficient is 2. Factors of that are 1, 2, negative 1, and negative 2. So when we get P over Q, we'll get 1 over 1, which is 1. 1 over 2, which is 1/2. 1 over negative 1 is negative 1, and 1 over negative 2 is negative 1/2. Now if we go down the line and put negative 1 over all these, if you go through, we get these same numbers. Okay, so again, we have 4 possibilities. Now it is time to find the true rational roots. So we're going to test with synthetic division. All right, so let's start with 1. Coefficients are 2, negative 1, 2, and negative 1. Bring it down, multiply, add, multiply, add, multiply, and add. Nope, that one didn't work. All right, let's try the next one. Let's do 1/2. 2, negative 1, 2, negative 1. Bring it down, multiply. 2 times 1/2 is just 1. If we keep adding 2 times 1/2 is 1. Hey, that one worked, so yes. So x equals 1/2 is a root. Okay, so let's see what equation we have left from this. All right, 0 is the remainder, 2 is a constant, we have 0 for the middle term, and then we have 2x squared. Okay, so that all equals 0 still. We get that from the very beginning up here. All right, so I've kind of been writing too largely. Okay, so I've got 2x squared plus 2 equals 0. From here, we still have to find all the other factors, or all the other zeros, which means we have to solve for x. Out of this, we can do that. Okay, so let's subtract 2 to the other side. So I've got 2x squared equals -2. I'm going to divide by 2. So I get x squared equals -1. I need to take the square root of both sides. When I take the square root of both sides, I have to write down plus minus. What's the square root of -1? I. There, we found our other roots. One last part, and it's pretty simple. Conjugates, new word, use it in Spanish class, it doesn't mean the same thing. Okay, when we have a pair of numbers that look very similar, the only thing different is their sign in the middle, not the outside, but the middle. So A is the same, BI is the same, it's just the plus and the minus that are different. Or like this here with the A and the square root of B, the only difference is the sign in the middle. Those are called conjugates. They have a very unique relationship that we can use to our advantage. The conjugate rule is that if one part of the conjugate pair is a root, then the other part is also a root. So for example, if 3 minus 14i is a root, what is also a root? 3 plus 14i. Alright, so you just found another root. If negative square root of 11 is a root, what is also a root? Okay, well we can think of this as if it had a 0 in front, so that would mean that positive square root of 11 is a root. Alright, one last problem that, simple concept but a little long. Alright, so we have a third degree polynomial equation, so that means it's got 3 zeros, with rational coefficients that has roots 3 and 1 plus I. So what is the other root? 1 minus I. Now we need to actually find the polynomial equation. So we're going to say, we have 3 factors here. We've got x minus 3 from the positive 3 root. We've got x minus 1 plus I from the next root, and x minus 1 minus I from the next root. Let's clean these up a little bit, get rid of some parentheses. So we've got x minus 3, and then x minus 1 minus I, and then x minus 1 plus I, when you distribute those negatives in. From here, always try to deal with the more complicated ones first. If it has an I, deal with those 2 factors first when you're simplifying, and we'll leave this one to last. That'll save you some trouble. Okay, so x minus 3 is still here. Now we need to distribute x times x, x squared. X times -1, negative x. X times I plus xi. -1 times x is minus x. -1 times -1 is plus 1. -1 times I is minus I. Negative I times x is negative xi. Negative I times -1 is negative I. Or wait, that would be positive I. My bad. Negative I times positive I is negative I squared. What does I squared equal? -1. Okay, so we've got minus I squared, so that's minus 1, so all of that makes plus 1. All right, let's simplify a little bit. Still have our x minus 3 in front. How many x squared terms do we have? Just the one. How many x terms did we have? We had 2, and they're both negative, so that makes negative 2x. What about xi? Well, we had 2, but they cancel each other out. One's positive, one's negative. Okay, what about I? The i's also cancel each other out. All we have left is plus 1 and plus 1, so that is plus 2. Okay, things just got a lot more simple. This is good. Now we got to distribute down here. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 2 is plus 2x. Negative 3 times x squared is minus 3x squared. Negative 3 times negative 2x is plus 6x. Negative 3 plus 2 is minus 6. Those are multiplied. So now simplify one more time. All right. Only one x cubed term. These together make negative 5x squared. These together make plus 8x, and minus 6 is at the end. Woo! There's our polynomial that has the roots of 3, 1 minus I, and 1 plus I.